I'm Jim with CyberRecon. Welcome to your daily dose of security education. Today we're going to jump into a topic that a lot of us are using today. VPNs are virtual private networks, how they work, what they're all about. As always, if you could, hit that like button, hit the bell to be notified when new content comes out, and subscribe if you would. That would be wonderful. But let's jump into the deck. So, this is part of Domain 2, Technologies and Tools for your Security Plus preparation. This is part of Subdomain 2.1, where we talk about the different networking components. Today's topic is virtual private networks, or VPNs, and what all encompass a VPN and how you can use it to your best advantage as the security person in your organization. So, here's what we're going to talk about it today. What is a VPN? What's a VPN concentrator? What's the difference between remote access and site-to-site access when we're talking about VPNs? What is IPsec and what does it encompass, the modes that it uses, like tunnel mode, transport mode? What about some of the protocols it uses, like AH and ESP? We'll look at split tunnel versus full tunnel, and then we'll look at TLS and how TLS is being used in your VPN. So, VPN, or Virtual Private Network, is a logical network that's established at the network layer of the OSI model. The logical network typically provides authentication and data confidentiality services for some or a subset of a larger physical network. From your friends at NIST, giving you a good definition like that. The good thing we need to know, it's a virtual secure network that we place over another network, like the internet. The other thing we note there, it's the OSI network layer, so we know that's layer 3 of the OSI model. And then if we need to talk about a concentrator is just that device that enables the VPN communications. Today we'll talk about a concentrator as if it was a separate device. For example, a Cisco 3030 is a specific device that has a sole purpose enabling VPN communications. Know that most routers and firewalls can also establish VPN tunnels, so it's important to know. We'll be talking about a specific concentrator. This is a physical device, but know that a VPN concentrator can be part of another device like a firewall or a router as well. We can use those for VPN as well. So, when we talk about IPsec, or IP security, or IPsec, again, layer 3, the network layer, provides authentication and encryption over IP networks. That's important. There's 2 modes, tunnel mode and transport mode. And there's 4 sub-protocols. AH, authentication header, encapsulated security payload, ESP, IPComp, and we're not going to talk about IPComp a lot this morning because it's not in the Security Plus body knowledge, but know that IP payload compression is handled through IPComp. So IP compression is what that stands for. And IKE negotiates shared key or key exchange, which is that shared secret that both ends need to know to be able to decrypt the traffic. So one end uses the same key to encrypt the traffic that the other end is going to use to decrypt the traffic. So we're using a shared key, a shared key between the session, right? So IKE handles that. So it's weird that Security Plus doesn't talk much about IPComp or IKE at this point, but that we will cover AH and ESP. Those are important to know when we talk about that. So that's some of the things that you need to know. So, in the 2 modes of using a VPN, there's tunnel mode and there's transport mode. So in transport mode, only the data is protected, and in tunnel mode, both the data and the IP header are protected. So I like to think of this as if your data is going through a tunnel, you really can't see anything. You can't see the data because it's encrypted. You can't see the header because that's encrypted as well. So you don't know where the traffic's going to or where the traffic is coming from, essentially. But then in transport mode, I think of this as your data's on the back of a truck. It's covered up by a tarp. You can't see what the data is, but you do see information about the header. So maybe you see where the truck's coming from, maybe the license plate, maybe the name of the truck, maybe what is logoed on the truck. So Good thing to know, you just got to know these two things. That tunnel mode, the data and the IP header are protected. And in transport mode, we only protect the data, right? We use protection on the data alone. And when we talk about protection here, we're talking about the encryption of that data. So next we talk about is AH versus ESP. And these two protocols we're going to use to protect our data or encrypt it or provide validation that it hasn't changed, right? So AH is the authentication header. That's what it stands for. It provides authentication of generally the entire data packet. It provides integrity. So when we're talking about our security triad or security objectives of confidentiality, integrity, and availability, the AH provides integrity that the data has not changed in transit. It does this through a checksum or a hash of the specific fields. Talk about that a little bit in a future slide in this deck. But it provides proof that that information hasn't changed as it's went across the internet. ESP, or encapsulating security payload, provides only encryption. So this provides confidentiality. We talk about our security triad. This is the encryption of the data, or depending on which mode we're in, the encryption of the data and the IP header. Uses symmetric logarithm, so it means it's a shared key. The sending unit and the receiving unit both use the same. For maximum protection, we want to use both AH and ESP. That way we have the integrity of the data and we have the confidentiality of the data as well, right? So it's important to know when we set up a VPN, are we doing it for remote access or are we doing it for a site-to-site connection? We talked about Concentrator earlier. This is an older Concentrator. This is a Cisco 3030. It only handles VPN communications. And again, these functions can be built into a firewall. They can be built into a router. So this one specifically is just a concentrator. So if you want to know what a VPN concentrator looks like, that's the Cisco 3030. A little bit of an older device, but it is still a concentrator. So you see in our corporate office, we have a VPN concentrator sitting there. And in a home office, where a lot of people are working right now, we're working remote, a lot of people, we've got to have the ability to connect securely to our workstation, our work center, our organization. So normally the way we're going to do this is through a remote access VPN session. So we're going to set up a session between our house, our home computer, or our work computer we brought home, and that VPN concentrator. So normally this is done with a piece of software that runs on a laptop or a desktop and connects into that VPN concentrator. Normally these aren't running all the time. Normally they're set up when a user is working, and there's a couple different modes we can log in to the software. So the other way is if we have another site, another organizational location, and we want to connect these two all the time. They're going to be generally connected all the time. That's when we're going to have a site-to-site connection. And normally we're not going to have software doing this. Normally we'll have two hardware devices, a hardware device on each side. So in this case, we're using specific VPN concentrators. This could be firewalls on both sides. It could be routers on both sides that provide the VPN functionality. But the big thing is there's devices on both sides. Behind those devices, the end users don't have to establish a VPN connection. The VPN connection will be handled when it hits that concentrator, and then at the other end it's let loose onto the network again. So know that generally that's the two modes of VPN connectivity, remote access. I think a lot of us are familiar with remote access now. We're using different types of software to log into our corporate networks from home, from our computers, and it's generally a piece of software you've got to run on your computer to get you access to that VPN concentrator on the other side. So the other thing we need to know is what is the difference between split tunneling and a full tunnel. So first we talk about this remote user, this home user that wants to go to Google. So in a full tunnel, when the user connects to the VPN concentrator, that's the only thing they're connected to. They're no longer connected to their home network. Now they're connected to the network at work. So for example, in this scenario where you've got a full tunnel, If you have a printer at your house and you're used to printing to that, when you connect your VPN to your organization and you're using a full tunnel, you will no longer be able to print to that printer, because your computer will not see that printer anymore. You'll be on a different network. You're going to be on your corporate network. If I'm on a full tunnel and I want to go to Google to check something out, that traffic will route. So the traffic will route from your house to the VPN concentrator and then to Google, and then the reply will come back down to the VPN concentrator and back to your house. And this is important because if there are rules in place at your organization that prevent you from going to specific sites, there's, say, a web proxy in place, those proxy rules will be in place. So if you try to go to some place from your VPN connector in full tunnel mode, then those rules will be applied. So if you try to go to a gambling site or something like that while you're logged in the VPN, you're going to get the warning. You may be blocked, you may be logged, you may get other actions taken. So the difference is, in a split tunnel, we establish one connection to the VPN concentrator at work, and specific network traffic is set to go to that network. But there's also a second network connection that's connected to your home network. And when you go to Google, you go through your home network. When you go to your work file share, you're going to go through the VPN connection. Now, this is less overhead on your organization because they're not going to have to route all that traffic to Google and back to them and then back out to you. The problem is that now that you've got two connections, you've got your one computer with a connection to your home network, to Google, and then you've got another connection to a VPN to your work network, where you're essentially sitting on your organizational local area network. You've created a bridge between your home network and the work network. And if you connect to something on your home network that maybe is a little bit malicious, it's going to have the ability to go through your computer and right to your organization. So a lot of the security protections that are in place at your organization can be bypassed if we allow split tunneling. So a lot of times, if an organization has built their VPN structure correctly, they will not allow split tunneling. So when you connect to your VPN, that's the only thing you'll connect to. You'll be connected to your organization, and that's all. So one of the things a lot of organizations will do is also an always-on VPN. So in essence, as soon as you turn your computer on, there's going to be a connection to the VPN concentrator. So you're never going to have the ability to log on to another network. You're never going to have the ability to go, say, to a website without going through your organizational structure. In an always-on VPN, as soon as you start your computer, as soon as you get your network up and running, it's going to connect to the VPN. So in these cases, you're always going to be connected. The security protocols from your organization are always going to be in place. You're not going to really have the ability to turn on or off your VPN. If your computer's on and the network stack is built, you're going to be connected to the VPN. And that's the way these are structured. So always on, just like it sounds, it's always on. It's always up and running, right? So the other thing you should know is some organizations will use TLS, or Transport Layer Security, for their connection to the VPN. This uses a well-known port, 443, which is used for HTTPS, or Secure Hypertext Transfer Protocol messages, secure web traffic. It's essentially a web-based VPN. It uses certificates for manual authentication. It replaces SSL. So if anybody's out there using an SSL VPN, that's bad. That's bad news. We shouldn't be using SSL for anything. There are far too many exploits for SSL, or secure socket layers. That should be gone everywhere. So if your organization has problems running what normal IPsec or normal VPN ports, like, for example, Cisco likes to use 500 or 4500 or 10,000, if those ports can't be used, sometimes it's easier to use a TLS VPN session or a web-based VPN using a well-known port that's usually open on most networks, like 443. So we talked earlier about what AH does. So AH is the authentication header. This provides integrity that the data has not changed from when it was sent from the originator to when it was received at the destination. The way it does this is it takes the data and it adds the IP header and then it adds the shared key. It runs that through a crypto hash, and it provides the authentication header. So if we know about hashing, we know that once we combine the data, the IP header, and the shared key, once we hash that, we're going to come up with the extremely complex mathematical function that ends up with a sequence of hexadecimal numbers, usually, that will indicate if any of that has changed. So in transit, if someone goes in and changes even a small amount of the data, a character, as a character, or adds malicious code, the hash changes, and it will indicate that that data has changed in transit. So that's how the AH value works. That's how we ensure that the data has not changed. We do that with a crypto function along the way, and some of the crypto hashes they use are MD5, SHA-1, or SHA-2. And really, of these, you should be using SHA-2. The other two, MD5 and SHA-1, are fairly insecure nowadays. So we should be using SHA-2. We do that hashing function. What's going to happen is the data will transit the network. And remember, with AH, the data is not encrypted. So when it gets to the other end, the receiver is going to see the same data, the same IP header. They're going to have their copy of the shared key, and they're going to run that same SHA-2 value. It should equal the same result. So when we add the data and the IP header and the shared key, and we run it through SHA-2, it should result in the exact same value. If it doesn't result in the exact same value, then we know that the data has been changed in transit. That's the importance of the AH. So we know that ESP encrypts the data, and AH provides our authentication or integrity check. So in transport mode, this is what your data looks like. And it's good to know this reference. I'm not sure that you're going to need to know it for the Security Plus exam, but it's good to see this as it lays out in a pseudo version of the IP packet that's going on. So normally we have our data. That's the thing we're trying to get to the other end, right? We're going to add that ESP header to it. We're going to have the AH header to it. And then we have our IP header. Remember, this is transport mode. So if you look here, we see our data is there, and our IP header is still the same, and it's leading the parade. It's getting us where we have to go, because that's what the IP header does. It provides that source and destination information. We also add an ESP trailer, and we add an integrity check to the back, right? So now we've got our packet. This is what it's going to look like. In transport mode, there's one more function we've got to do, and we've got to encrypt the data, right? So the trailer gets encrypted as well, and now it's encrypted, right? So now we have, this is the only portion of the packet that's encrypted, and we've done that by just scrambling the letters in this example. So this portion's encrypted, the rest of it is authenticated, right? So if we look in the tunnel mode, we have our data there as well. In front of it is the IP header. In front of that is an ESP header. An AH header's in front of that. There's also a new IP address attached to the front, so we know where we're going. There's an integrity check. And in this case, we have all of this information that's encrypted. And of course, the new IP header in the front provides our destination information. So that is the rundown on a weird day that doesn't seem to be, seems to be gremlins are everywhere today. So hopefully that provides you a good overview of VPN, what you need to know for the Security Plus exam, what you need to know for the basics of being in security. So need to know what a VPN is, know what a VPN concentrator is, know the difference between remote access and site-to-site access, know the things about IPsec, know the difference between tunnel mode and transport mode, know what AH does and know what ESP does, know the difference between a split tunnel and a full tunnel, know what the always-on connection is, and know about TLS, why we use TLS and what it's all about. But as always, I'm Jim with Cyber Recon. Hopefully you're having a good day. Hit the bell, like, comment, subscribe. Love to hear what you got to say. As always, be safe out there, and we'll see you next time.